You. You suck.
We gotta get the Mavericks in.
Amanda's gonna walk in right now.
You look great.
Watch everyone walking right now.
Madison, get in here.
Wait, there's no cookies?
What? What? Where?
Addison, can you explain what we're doing here today?
I don't know.
Can you explain what we're going to be doing here today?
So we're gonna be helping at the FLL mock tournament for Girl Scouts of Orange County, and our team will be helping act as the judges.
Do you have anything to say, Isaac?
No, I think she's covered everything. We are really excited to be here today, and we thank all the Girl Scouts for letting us come out here and help out with the judging process.
I'm the chug. Which one?
How many do you have in this room?
6. Great. So then we'll do that one because they only have 5 in that one.
But she's in my 0 period. I have no idea who that is.
Wait, dude, he's so good at this.
Okay, thank you. Are there any other questions for you guys?
Did you guys have any like specific things that spurred the idea of this model, the one that you guys have here?
I love swimming in my pool and I love waterfalls. So I thought that having a waterfall in a pool that could create energy for your home would be a really cool idea. Yeah. In the front. 2 color sensors and 2 color sensors. There are 2 motorized wheels that are inside and 2. We have 4 attachments. All 4 attachments are passive and do not require a motor. We have the cage, the funnel, the catcher, and the dropper. The cage is used to pick up energy. The funnel is used to square up against the oil platform and complete the mission. The catcher is used to catch falling energy and is passive. The dropper is used so when the main trigger is pushed, the opening has energy units and it will drop. The missions we have completed so far are the ones we have either made an attachment for.
So what made you decide on doing that instead of using a motor for these attachments?
Because of the limited amount of time we had, we decided that if we used passive attachments, it would be a lot easier for us to code more of missions as well.
One thing about the competition is that you do have a certain amount of time. So sometimes when you're making attachments, you have to know exactly how to switch them out or what to do when switching them out and have to think about how long it'll take for you to switch them out. What makes your attachments so efficient when you have to come back and change them out?
I did like how you guys put pictures on your board. I thought that was nice, and I liked your physical demonstration.
I think you guys did awesome on that. Good job.
I think one good thing that you guys could try doing is keeping a list of problems that you guys have faced and then the solutions you made for the problems, so that way, let's say a judge asks you what are some specific things you did, then you can
And I'd like to add on to that. You mentioned that the term by gyro code, you got it from your mentors. Would you be able to explain how it works if you were asked about it?
I really liked how you guys explained the purpose of various decisions you made or parts that you had. I wish you guys had done it a little bit more because I think there were instances where you would kind of explain a lot of parts but not really your purpose or decision making, which is important for like iteration in your design process. But I think it was good that you acknowledged you made multiple designs. And like Shayde said, I think you guys know what you're talking about, so it would be nice if you were looking at the audience and projecting a little more.
a situation that either all of you can apply to or each of you can apply yourselves to, so that way you guys are all prepared for each of the different questions they can ask.
Because the judges can really tell if you've had fun or not, or if you're just faking it. So actually have fun together. But you guys did so good.
Yeah.
Really detailed for the most part. Part of the engineering design process. We're never satisfied with what we have. We always want to make it better. This first thing, so my challenge, she asked the question of, we weren't very clear on your the problem that you're trying to solve, because you opened with, let me tell you about greenhouses, but we didn't know why you guys.
You should try to structure like your explanation more, because you guys had a lot of good points and research, but it could definitely, if you structured it better, you would not have to ask like clarifying questions.
I had a question about, well, not question, but feedback on your robot design. Maybe in since this is a mock tournament, but an actual tournament, I recommend that you talk a little more about your code because I didn't hear much about it. But other than that, everything else was really
Talk about building your design for the catcher in your presentation because that was actually really fascinating to hear about. And so if you brought that up without us having to ask you, it really shows that you noticed that.
Is that how it was?
Hi, right now we're going over our grading rubric for one of the matches that we first watched, and we're making sure that we checked off the correct point values for every mission they completed.
So basically, we judge each mission that's completed by students. For example, the first one, we gave them 10 points because they fully completed what they were supposed to do. They were supposed to put an object in a certain area. And we gave them 150 points for what they've completed.
Okay, for solar farm, I give it a full score because we removed all the circles from this area, and that's 15. And the bonus is they remove all three, so that's 5. It's 5 each, and the bonus of 5, and it's fun.
I really think that knowing where you are, being able to align yourself and position yourself properly is really important in this challenge. They have the sensors and everything on the ground with the lines so you can tell where you are. Everything in this challenge is really position oriented and aim oriented, and everything has to be done automatically without any human input. So I think being able to know where you are and work based off that is really important.
What did they do to chemists after they die? They bury them.
Alright, so I saw someone, they have all their dolls lined up outside next to their outdoor grill. Looks like they're about to have a barbecue. Boo!
How does the ocean greet people? It waves.
Alright, how many programmers does it take to change a light bulb? None. That's a hardware issue.
My name is Emma. My name is Kaylee. My name is Cora. Discovery, we explore new skills and ideas. Innovation, we use creativity and persistence to solve problems. Impact, we apply what we learn to improve our world. Inclusion, we respect each other and embrace our differences. Teamwork, we're stronger when we work together. Fun. is 6 kilowatts. 6 kilowatts.
Thank you. Another question right over here.
Regarding space constraints and also having the water fall from high heights, how does that work with like property limitations when you
Make sure to subscribe and hit that like button. Don't forget.
Honestly, though,
Oh my gosh.
go for it.
Here,
What the
give me
hell
your
is
other
that?
thing. Give me.
My arm's not supporting.